Hello, dear attendees. I'm Mehmet Cevat TEMİZKAN from Yozgat Bozok University, Faculty of Veterinary Medicine, Department of Genetics. Today, my topic is design of an assay for detecting Ehlers-Danlos syndrome in Bengal cats via enzymatic digestion. Ehlers-Danlos syndrome, clinically termed feline cutaneous asthenia, is a heritable connective tissue disorder characterized by skin hyperextensibility, fragility, and delayed wound healing due to defective collagen fibrillogenesis. While the condition is sporadic in the general feline population, specific pathogenic variants, particularly within the COL5A1 gene, have been identified in the Bengal breed, manifesting as a clinical phenotype of severe dermal instability and atrophic scarring. The etiology involves a defect in collagen fibrillogenesis. The mechanism of Ehlers-Danlos syndrome in cats type 5 collagen acts as a critical nucleator and regulator of type 1 collagen fibril diameter. Mutations in COL5A1 gene disrupt this regulatory function, leading to collagen dysplasia. Histologically, the collagen fibers in the dermis become irregular, fragmented, and loosely packed. As a result, this structural anomaly significantly reduces the tensile strength of the skin, despite the skin appearing visually normal until trauma occurs. Bengal cats with Ehlers-Danlos syndrome will present distinct dermatologic signs due to the active nature of the breed. Skin fragility is the most important sign. The skin tears with minimal force and abnormally elastic and can be scratched far from body called hyperextensibility. Fish mouth wounds appear, like lacerations typically do not bleed heavily but gape significantly, resembling a fish's mouth. Wounds heal with thin, wrinkled scars, often described as cigarette paper scars. So here you can see a Bengal cat with Ehlers-Danlos syndrome. The mutation in Bengal cats appear to be breed-specific and exhibits an autosomal dominant pattern of inheritance. The etiology of the disease involves a 22 base pair deletion of the COL5A1 gene situated at the exon 1 intron 1 boundary. This alteration is thought to compromise the splicing mechanism, resulting in the formation of an abnormal protein that underlies the clinical phenotype. In this study, I aim to design a cost-effective and rapid molecular diagnostic method to detect COL5A1 variation responsible for Ehlers-Danlos syndrome in Bengal cats. By developing a PCR RFLP assay, a practical alternative to sequencing is created. This method aims for easier and more affordable Ehlers-Danlos syndrome detection, enabling quick screening and better breeding management for breeders and veterinary practitioners. To achieve this, I follow the in silico workflow to design the diagnostic assay. Let me show you what I did. First, I started with OMIA, Online Mendelian Inheritance in Animals database. I used this database to retrieve the specific phenotype and genotype details of Ehlers-Danlos syndrome in cats. This confirmed the key variant as an autosomal dominant trait linked to the COL5A1 gene. Once the target gene was identified, I accessed the NCBI Gene Bank database. Here I obtained the reference genomic sequences from the feline COL5A1 gene to serve as a template for the design. To get more detailed view of the gene structure, specifically the exon intron boundaries, I used Ensemble Genome Browser. This was crucial for locating the specific exon 1 intron 1 boundary where the pathogenic 22 base pair deletion occurs. The core of our RFLP assay is selecting the right enzyme. So I imported the target sequence into NAPCutter. I performed the restriction site analysis to find enzymes that could distinguish between the wild type and the mutant alleles based on the presence of absence of that 22 base pair deletion. For the amplification of the specific target region, I moved to primer design. So I used Primer software to design a pair of primers that would flank the variation site. Then I validated the designed primers using NCBI Primer Blast to ensure they would bind only to my target region in the cat genome and not produce any non-specific products. Finally, with that step, I created simulation of the gel electrophrases of specific region cut by enzymes. And here is my result. You can see here the key mutation detection year, the accession numbers of NCBI ensemble, and the primers I designed, and the enzymes I found, which cuts exactly from the location we want to. And this is the simulated gel electrophrases results, shows that BFU-A1 and BSP-M1 creates very clear distinguish between wild-type allele and mutant allele. And this is the similar result for BSE-Y1. So we can clearly distinguish wild-type and mutant. Ehlers-Danlos syndrome in Bengal cats present a significant welfare concern due to severe skin fragility associated with collagen dysplasia. While the clinical symptoms are distinctive, definitive diagnosis has historically relied on expensive sequencing methods or invasive skin biopsies. This study focused on the specific 22 base pair deletion at the exon 1, intron 1 boundary of the COL5IA1 gene, confirming it as a reliable marker for molecular diagnosis. Targeting this breed-specific mutation allows for a precise distinction between affected individuals and those with other dermatologic conditions. The PCR-RFLP assay developed in this research offers a substantial advantage over traditional diagnostic techniques. Sequencing requires specialized equipment and longer turnaround times and higher costs. This enzymatic digestion method provides a rapid and binary result identifiable via standard agarose gel electrophoresis. The specific simulated cleavage patterns of BFU-A1, BSP-M1, and BSE-Y1 enzymes successfully differentiated between wild-type and mutant alleles, demonstrating the assay's sensitivity and cost-effectiveness for routine laboratory settings. Implementing this diagnostic tool has profound implications for veterinary practitioners and breeders. Given the autosomal dominant inheritance pattern of Ehlers-Danlos syndrome in Bengal cats, early identification of affected individuals is crucial for preventing the vertical transmission of the defective gene. This assay empowers breeders to make informed selection decisions, eliminating the disease from the breeding lines. Furthermore, it enables veterinarians to provide definitive diagnosis quickly, allowing for immediate management strategies to minimize trauma and improve the quality of life for affected cats. Thank you very much for listening.